Hi, Year 11, Mr. Green here to take you through one of the lessons on the forces topic. This is distance time graphs. Our learning objective today is to explain objects' motion using distance time graphs. If you could pause the video and write that down as your lesson objective. Okay, first up, some retrieval questions. 5 questions. If you can just pause the video and attempt all 5 in your books, please. And pause. Okay, question 1. An example of a scalar quantity. There's quite a few we could give. I've given a few here. Distance, time, mass and speed are all examples of scalar quantities. Remember, a scalar has a size but no direction. Question 2. An example of a vector quantity. Well, a vector would have size and direction. So I've given you displacement, force, velocity, acceleration. There's many more of both of those, but as long as you have something for scalar that has a size but no direction, whereas in a vector, size and direction, you're not going to go wrong. Question 3. What equation links force, extension and spring constant? Again, remember this is force, extension and spring constant, not energy, extension and spring constant. So this equation would be force equals spring constant times extension. What equation links mass, weight and gravitational field strength? So another equation you need to know for your exam. That's weight equals mass times gravitational field strength. And finally, what equation links speed, time and distance? Speed equals distance divided by time. Make sure you pause the video, green pen your answers and make sure you've got all those answers down. Okay, today's learning outcome is to draw and interpret distance time graphs, describe the motion of an object by analysing a distance time graph and explain how the gradient can be used to calculate the speed of an object. For this lesson you will need graph paper, a pencil, a ruler and a calculator. So if you could pause the video and gather those materials. Okay, so how could we show an object's motion graphically? In order to get a graph we need to have at least 2 figures. We need 2 sets of data. So we need 2 things we can measure as far as measurements can go. We need two numerical figures. Fortunately for speed and for a motion we have distance and time. So there's a quick distance time graph. Have a look at that. And it's going to disappear in 3, 2, 1. Okay, in your books, could you please recreate that graph, labels and everything? I'm going to give you 2 minutes to do that. Please pause the video while that happens. Okay, it's going to return on here now. So, there's our distance time graph and we can see the differences between them. How steep the slope is tells you how fast that's going. The steeper the slope, the faster the object is. If it's horizontal, that means it's stationary, it's not moving at all. And again, these are all going at a steady speed. If it is a straight line, it is a steady speed. Our key facts for these, your y-axis, so the side axis always needs to be distance. The x-axis along the bottom always needs to be time. And for a distance time graph, I won't ever tell you to do this again, but for a distance time graph you need to join the points dot to dot. Okay, if you grab your graph paper and your ruler, there are 3 sets of data here for you to plot. I'd like you to plot all this data on the same graph, please. So your x-axis needs to go up to 100, your y-axis needs to go up to 260. Okay, if you could pause the video whilst you attempt those graphs. Okay, the graph should look a bit like this, but from this graph on the board there's quite a lot missing from there. You need to ensure this information is not missing from your graph. So we need to ensure we have labelled each axis. We've labelled the y-axis as distance and the x-axis as time with our units, meters and seconds. We then also need to ensure we have labelled our plots. Okay, so with our graphs, what does the graph tell you about their motion? Well, they're all straight line graphs, so they all travel at a constant, steady speed. You need to think, if their speed had changed, what would happen to the line? What shape would it take? From those three, who is moving at the greatest speed? So we're looking at the cat is moving at the greatest speed. He's travelled the biggest distance in the shortest time. But how can we tell by just glancing at that graph? Well, we can tell because the cat has got the steepest gradient on there. The steepest gradient means the biggest distance in the shortest time. Okay, how can we use the distance time graph to find the speed? Well, looking at that there, we can use a distance time graph because the gradient of a distance time graph represents the speed. So whenever there is a slope on there, we can work out the gradient. That's the distance up divided by the distance across. Use your axis and your figures to work those out. So during part A, what's the motion? Pause the video, discuss that with each other. Okay, during part A of that graph, they're travelling at a steady or a constant speed. What's the motion during part B? Again, pause the video and discuss this. During part B, stationary. What's the motion part C? Again, same as before, it's a steady or a constant speed, so at D, that must be stationary, not moving at all. But for this graph, during part D on that graph, what's happened to that? So during part D, that car is stationary, it's not moving, it is horizontal to the x-axis. But what's happening during B? During B, that is a straight line. When we get a straight line on a distance time graph, that means it's travelling at a steady or a constant speed. So what will be happening at A? At A, the gradient is changing. The gradient is going from a low gradient to a higher gradient. The steeper the gradient, the faster it is. So if the gradient is changing, the speed's changing, which would mean it was accelerating. Okay, I'll leave that on the board. If you could pause the video, you've got a 4-mark question there, distance time graph of the car. Explain what figure 1 shows about the motion of the car between point A and point E. Use values from figure 1 in your answer. 4 marks available. Pause the video, give yourselves 4 minutes. Okay, here's the mark scheme. Again, pause the video, go through each point on the mark scheme. If you've hit 4 of those points, give your mark. Anything you've missed, please get in green pen underneath your answer so you can know what you're missing. So pause the video to get those answers. Okay, how could we work out the speed at 10 seconds here? We know the car's accelerating at A, but how can we work out this instantaneous speed? At B it would be easy, we'd just take the gradient, but at A the gradient's changing. What we'd do is, we would draw a tangent at 10 seconds. A tangent is a line that is touching that which is almost the same either side of the line. Draw that tangent, use it to draw a triangle, get your values from your graph. That would be 200 divided by 17 seconds gives us a speed of 11.8 meters per second. So, in order to do this, we need to draw a tangent, a straight line that touches the curve. Measure the distance and the time from the triangle you'll make from that, and calculate the gradient, which is distance divided by time. Pause the video and copy those down. Okay, you have a worksheet with these values on there. I would use the tangents here to calculate the speed. Could you calculate the speed for graph 1 at 60 seconds, for graph 2 at 10 seconds, for graph 3 at 5 seconds, for graph 4 at 10 seconds, and for graph 5 at 4 seconds and 10 seconds? You'll need to make sure you draw it on the graph, you need to make sure you show you're working out there, and you need to make sure you are showing exactly how big your triangle is. The bigger your triangle is in this case, the easier it is to be able to calculate. Okay, 6-mark exam question. 2 girls, A and B, ran an 800-metre race. The figure shows how the distance changed with time. Compare the motions of runners A and B and include data. Pause the video. 6-mark question here. Okay, here's the mark scheme for that. Again, pause the video, ensure you've got all the marks you can possibly get there, and again look at the value of keeping your figures in there. Anytime you mention a figure, you'll get a mark there. Okay, that's the end of the lesson on distance time graphs. There are worksheets available for you to practice on. Anything you've not understood, please review the video again, and again come and see me if you do have any issues. Thanks very much for your time, Year 11. See you soon.